directed acyclic graph. It is also called DAG. So it is a directed graph with no cycle. Acyclic means no cycle. So it is a directed graph with no cycle. Topological sort. Topological sort is used in DAG to find the ordering for any directed as UV, that means U2V. The ordering is such that you must appear in B in the ordering for each UV pair. Topological sorting is not possible if the graph is not a DAG. Let's see an example. So how to do topological sort? We have to count the in degrees of every vertex. Here 5 has in degree 0, 4 has in degree 0, 2 has in degree 1, 1 has in degree 1, 3 has in degree 2. So first we will remove a vertex with in degree 0. Let's remove 5. Okay, and add it to the sort. When we remove, sorry, it has in degree 2. So we remove 5 and this connected edge. Now 2 has in degree 0 and 0 has in degree 1. Now remove 2 or 4. We can remove anything, 2 or 4. Let's remove 4. This is not mandatory to remove 4. So we remove 4 and is vertex. So 4 is removed. Now which has in degree 0? After removing 4, 0 has in degree 0. Let's remove, we can remove either 2 or 0 or 1. Let's remove 2. Now 3 has in degree 1. Okay, let's remove, now we can remove 0 or 1. Let's remove 0. 1 because it has in degree 0. Now 3 has in degree 0. Remove 3. This is our topological sort 54213. This is necessarily not unique. Let's see how to code. B equals 6, number of vertex. These are edges given 2, 3, 3, 1, dot 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 5, 2. Dot dot means there are many edges between from collections import default dictionary. We keep track of in degrees of the verb text. So in degree equal default dictionary int types. That means in the dictionary, suppose this is the dictionary, this is a key A, it will have the value like int type. So suppose it's 4, B key A, suppose 7. Okay. So key value. So the value type will be int. That means in degree default dictionary int. Adjacency list. Default dictionary list. It will create a is adjacency list. It means what is the neighbor of A? Suppose B, C, F, K. Okay. And they will be embedded into a list. So key value. The values are in a list. So default dictionary list. Actually, this adjacency list means the adjacency representation of the graph. Yet we don't have the collection of all vertex. So it is a set of vertex. All the vertex into the graph. Okay. So let's find the in degree and adjacency list of the given edge list representation of graph. For edge in edges, in degree of edge 1 plus equal 1 plus equal 1. That means suppose 1 to 2 is a edge. So that means 1, 2, 2. That means in degree of 2, if it is 0, then we will increment it by 1. So it will be 2. In degree of 2 is 1. In degree of 2 is 1. In degree as 1, as 1, as 0, as 1. As 1, it will increment by 1. adjacency list representation. Now we know vertex is a set. So we are vertex dot append as 0, vertex dot append as 1. As vertex is a set, any duplicate will be removed, only the unique vertexes will be contained in vertex. Now, in degree contains, while doing this, only the second base is counted because it has in degree, but the first base may not have in degree. So we have to find all the vertices that have in degree 0. So x1 equal to vertex, that means all the vertices in the graph, then remove we remove. This is all the vertex in the graph, and we remove the portion of set in degree dot keys. So this have in degree greater than or equal to 1. So these are all the vertex, and this portion has in degree greater than or equal to 1. So this portion will have in degree equal 0. So x1 is the set of vertex that has in degree 0. For I in x1 in degree I equal 0. So we found all the new degrees including 0. Serial is our desired output of the topological sort. Define topological sort. What we pass in degree, we pass adjacency list of the graph. We are accessing and modifying the serial outside the scope of our function. So we declare serial as global serial. Otherwise, it will return a scope error for I in degree dot keys. That means the edges and their in degrees. This is the in degree value and this is the edge. Okay. So in degree dot keys means the edges. If if I has in degree 0 and I is not included in the serial, not in serial, what do we do? We remove I. Previously we seen the vertex with in degree 0 is removed first. Okay, and we decrease the in degree count of the other vertex. So we delete and append it to the serial the this vertex and we remove decrease the in degree count of the other vertex. So this is what we do. If we in append serial dot append I if already not in serial and we decrease the in degree count of its neighbor. So for j in adjacency list of I in degree of I means in degree of I means its neighbors. Sorry. For j in adjacency list of I, okay, we decrease the in degree of j by 1. So we continue this as long as in degree there is 0 and I not in serial. So we recursively topological sort. What is topological sort? In degree. We modify in degree and pass it again on adjacency list. Also, pass adjacency list. We need not modify adjacency list because we just modify in degree count and remove the key from the adjacency list. That means we don't remove, we just append the key to the serial. Okay. So topological sort in degree adjacency list. This will continue until the base case in degree I equal 0 and I not in serial becomes 4. So this is our base case of the recursion when this algorithm stops. We call the function. Enter output serial. So what is the complexity? Time complexity complexity is big of vertex plus edge, because we this portion eventually becomes in degree 0, and we travel every neighboring vertex, and every neighboring vertex to this connection means one edge. So the total time complexity is big of vertex plus s. And space complexity in this algorithm, especially big of v. Why big of v? Because we maintain serial and in degree lists. So time complexity big of vertex plus space complexity big of v. Advantage or advantage uses. Why we use topological sort? It helps in scheduling tasks. It detects cycles in a directed graph. Suppose after topological sort, in the graph there are 10 vertices, but in the topological sort there is 8 vertices. So 2 vertices is not included in the sort. So the two vertices may be dependent on each other, or it is creating a cycle. Suppose 1, 2, 3. After topological sort, 1, remove 1. Okay. Sorry. Can we remove 1? Actually, remove 1. No. Because 1 has in degree 1, 2 has in degree 1, 3 has in degree 1. So we cannot remove any vertex. So if we cannot include all the vertex in the topological sort, there must be a cycle. We can use topological sort in deadlock detection in operating system. You can see details in Google. What is deadlock? Deadlock means a process is dependent on another process, and this process also dependent on this process, a cycle. And whatever, this is out of the scope. What is the disadvantage? Topological sort may not be unique, because multiple, we have previously seen multiple vertex can have in degree 0, so we can remove any of the vertex. So this is not always unique.